Welcome to The Explainer. Today, we're unpacking a really fascinating paradox that's just sweeping through the tech industry right now. You've probably felt it. There's this intoxicating, almost feverish hype surrounding AI coding agents. We are constantly hearing that AI has completely changed the game, that agents are autonomously writing massive chunks of software, and that engineering, as we know it, will literally never be the same. But as we'll see today, the reality behind this sheer avalanche of viral hype is far more dangerous and honestly way more interesting than those breathless tweets suggest. Okay, let's just dive right in by posing a super simple but absolutely crucial question. With the introduction of these powerful AI tools, we are writing code faster than ever before. The time it takes to produce a pull request has literally plummeted. So, why aren't our products getting any better? I mean, if the machine is basically writing the machine, the rate at which our software improves should be accelerating exponentially. But for the vast majority of companies, it just isn't. To understand why, we really need to look past the hype. Section 1. The K-shaped AI reality. So on one side, you've got the hype. You know the posts. Those hyper-caffeinated founders claiming they cleared 6 years of backlog in a single weekend, or that 2 engineers built an entire backend in 3 days, doing the work of 20. But when we contrast those viral claims with the sobering reality that labor economists are actually observing, a very, very different picture emerges. The data actually shows a distinct K-shaped productivity curve. Take a look at how uneven these gains actually are. Since the AI inflection point, senior engineers are indeed seeing a measurable, solid growth in output. They sit comfortably on the upward arm of that K. But look at the junior engineers. Their output has essentially gone flat, or in some cases, it's actually declined. The productivity gains from AI are completely uneven. The speed is definitely there, but really only for those who already deeply, deeply understand the systems they're building. Section 2. The AI bloat problem. So what exactly happens when an entire industry blindly trusts this uneven productivity curve and just optimizes purely for speed? Well, look at this incredible quote from Docs. He's literally building an AI coding agent right now. He recently told his team that they're struggling to figure out the best way to use these agents, while pointing out the deep, hilarious irony that everyone else on the internet claims to be moving at unheard of speeds. When the very experts building the frontier AI tools are hitting a wall and questioning the narrative, we definitely need to pay attention. And this brings us to a huge reality check from David Kramer, the creator of Sentry. He points out that while LLMs absolutely remove the barrier to getting started, they struggle incredibly hard with incremental complexity. They fail to create simplified idiomatic interfaces. Instead, they just create increasingly complex software that doesn't appear to be maintainable at all. As he bluntly puts it, it's mostly bloat. AI speeds up the beginning of a project for sure, but it severely slows down long-term velocity. This whole phenomenon has actually given rise to a fantastic new term, slopulence. It perfectly describes the messy middle of AI adoption. It's what happens when you vibe code. You know, throwing a vague prompt at an AI, grabbing a coffee, and coming back to a sprawling mess of fast, unmaintainable software. You didn't write a strict specification, you didn't delegate specific architectural decisions, you got something fast, absolutely. But it's unmaintainable, it's just fast slop. Section 3. Code as a liability. Here is the hard truth, and it's a huge paradigm shift. Code is not an asset you produce, it's a budget you spend. It sounds totally counterintuitive, right? But the absolute best engineering cultures in the world view their codebase as a massive liability on their balance sheet. Software engineering is not about optimizing for maximum lines of code per hour. You are spending code to get a feature. You're not trying to hoard it. Let's break down exactly why that is. Every single line of code that you or your AI agent writes represents a new surface area for bugs to hide. It represents a new dependency that has to be managed. And worst of all, it represents compounding complexity. Product surface area expands fractally. If you add a Slack integration today, well, tomorrow you're going to need a Teams integration, and then an email fallback, and then enterprise policies. Complexity doesn't just scale linearly, it compounds. To really hammer this home, think about the famous anecdote about TinyChat. Their engineering team explicitly set up alarms that would trigger if the codebase exceeded a certain size limit. And more importantly, they didn't pop champagne for shipping 10,000 lines of code. They actively cheered when code was deleted. Elite teams actively fight against codebase mass because they inherently know that less code means a healthier, much more maintainable product. Section 4. Compression over production. Let's fit a David against a Goliath here to really see the difference between mass and quality. Look at Linear. They have just 178 employees, an extremely small code base, yet they deliver incredibly high consumer quality. Now look at Jira, tens of thousands of employees, a code base that is literally 56 times larger, and yet the perceived consumer quality is lower. Quality and code-based mass are absolutely not the same thing. At the absolute highest scales of engineering, the goal is system compression, not token production. Think about Facebook. Their constraint isn't how fast they can write user interface code. A competent engineer could mock up a feed in a day. Their actual constraint is compressing the code required to deliver that experience to billions of people reliably under massive load. AI coding agents currently lack the theory of the system required to actually make those long-term compression trade-offs. Section 5, the artisan's advantage. So if code is a liability, then your ultimate competitive advantage isn't typing speed. It's what the sources call subtractive taste. This is the deliberate, artisan decision to build less, to delete more, to actively compress the system, and to flat-out refuse unnecessary features. This highly specific, creative vision of what to leave out is incredibly rare. And crucially, it's not on any AI model's roadmap. Which leads to this really fascinating dynamic. AI is perfect for accelerating the building of standard, run-of-the-mill software. It helps anyone build a perfectly functional Camry competitor, dramatically reducing the time it takes to get a working version. But it doesn't help the artisans at Ferrari make a faster Ferrari. Frontier products demand subtractive taste. You can't just sprint through a backlog of features to push the boundaries of what truly good software feels like. Section 6, measuring learning, not output. We really need to abandon our old agile reflexes here. Organizations have to stop measuring token to output, counting pull requests, lines of code, sheer volume. Instead, we must shift to measuring token to learning, because the bill for all these AI tokens is eventually going to come due, and management will want to know what actually changed. We should be asking, did we close our iteration loops faster? Did our decisions actually improve? Did we use AI to kill a bad idea early? To actually achieve this, companies need to develop what the sources call loop intelligence. Loop intelligence looks at the work being done and asks, which product ideas were killed early because a rapid AI prototype revealed their flaws? Which engineering decisions actually got sharper? Which teams discovered reusable patterns that can be shared across the entire organization? This is how a company actually metabolizes the raw speed that AI provides, turning individual productivity into real organizational capability. The warning here is pretty stark. Without loop intelligence, if you just let everyone use AI to maximize their sheer output, you are basically buying speed with money you're going to have to pay back later. You risk filling the rafters of your software factory with chaos, slopulence, and massively compounding technical debt. And eventually, a real human engineer is going to have to climb up there with a broom and clean out all that slopulence. Which brings us to our final thought. Take a close look at how your team operates today. Is your organization actually building a learning system that metabolizes AI to make smarter, more subtractive decisions? Or did you just buy a lot of software seats to generate an unmaintainable mountain of bloat? It's a highly provocative question, but in the messy middle of AI adoption, your answer to it is going to determine your survival. Thanks for joining me on this explainer, and I really hope this helps you look at your next AI-generated pull request just a little bit differently.